Hello, we are Team 14 and this is our final presentation for our app, Waterchat. So what is Waterchat? Waterchat is a reliable messaging system for mobile users which uses wireless mesh networking to enable smartphones without internet or cellular service. So how does it do that exactly? Well, users can connect via Apple's multi-peer connectivity framework, which uses either Wi-Fi or Bluetooth depending on availability. This is a simple topology. A number of devices form a network and messages are transmitted via connection between any two smartphones. All functionalities are built on top of this fundamental infrastructure. Now I'm going to talk about the implementation of our Waterchat app. To identify smartphones, we need a unique identifier to distinguish between devices. Instead of requiring a unique display name or username, we simply use MAC address to identify users. Users can choose any display name and we map it to the device MAC address. And there is no other configuration required to get the app running. It's really easy and really simple. There are many routing protocols for ad hoc networks. We decided to use AODV, Ad Hoc On-Demand Distance Vector Routing Protocol, to implement, because the route is only created when it is required, instead of exchanging control messages periodically. This way, there is no wasted energy or computation resources when users aren't active. We also implemented a message passer similar to the one we did in our labs. This supports one-to-one or unicast communication, broadcast, and multicast. It provides basic functionality to the application layer. Encapsulation is also implemented to support a clean interface between different layers. Apple multi-peer connectivity framework is limited by Bluetooth range, so to find all users in a network, we implemented multi-hop communication for peers that aren't directly connected. When a new peer joins the network, their presence is broadcast to all users in that network. The peers also make this announcement every n seconds to guarantee liveliness and announce their own presence to any newly joined peers. In our group chats, there are three main functionality. Groups can be created, updated, and deleted. Any user can create a group, name it, and participate in it. After a group is created, it is accessible to the public, and any user can join the group and start chatting. When a new member joins the group, everyone needs to be informed of the new addition so that they may update their group member lists. The same needs to be done when a user leaves a group. A group gets automatically deleted whenever the number of users inside of that group reaches 0. Messages in group chats are sent via multicasting, similar to our lab assignments. We use a heartbeat method to inform peers of group creation, updates, and deletion. After users launch Waterchat, they'll first be greeted by a welcome page and a Waterchat logo. When users create the Join button, they'll get to the profile registration page you see on the left. Here they enter their name, gender, birthday, and additional information. Once they hit Join, they now officially join the network as a peer, and their user list becomes populated with all of the other peers in the network. They can also go to the other tab, which is the Rooms list. In the Rooms list, they'll see all the current rooms or groups that are available. They can join these rooms and start chatting right away. Now we're going to move on to the skills challenge of our project. Our main challenge was learning the programming language Swift and getting comfortable with it. None of us had used Swift before, so we had to get up to speed very quickly. Also, none of us were familiar with UI design using Xcode Storyboard, so this was another challenge. One day, out of nowhere, our code suddenly had 20 errors in it, and we had no idea why. It turns out that Xcode automatically updated, and part of that update was the release of Swift 1.2. This caused us some headache, and we had to modify our existing code to comply with the new Swift SDK. Another challenge we faced was testing. Xcode only lets you launch one instance of an iOS simulator, so if you didn't have any devices to test on, you couldn't test messaging without a teammate being there. And finally, registering an iOS device for testing was a tedious process and required adding our device IDs to the Apple developer account. Here are the lessons we learned from using Swift in our project. Using Swift in Xcode made it relatively easy to create an app. Swift was much cleaner to use than Objective-C from what we can tell. Also, Swift was easy to learn with great support and documentation from Apple. We can confidently say that we know Swift well enough to put it on our resume. In summary, we do recommend using Swift and iOS. We say this because it's a nice change of pace from Java, which we've been using all semester. Also, if you intend on developing iOS apps, there really is no other option, unless you want to use Objective-C, which is getting outdated. We do have some words of caution though. Swift is still very new and constantly being updated, and its libraries are not as extensive as Java since it is such a new language. Here is how we organized our team. We used Git and GitHub to manage our codebase. Everyone worked on their own branch, and then we finally merged to master branch. We held weekly team meetings to discuss features, do pair programming, and conduct testing. This is how we split up the work. Mike worked on the networking layer, Ding worked on the user interface, and myself and Anne worked on the application layer. Finally, we'd like to thank you for watching our presentation. We had a great time working on this project this semester.